Welcome to the introduction of SQL Group By. In this session, you will learn how to group data for powerful aggregation and analysis. Let's begin. Here, let's explore the purpose of the Group By clause. The Group By clause is used to organize data into groups based on column values. It enables aggregate functions to be applied on each group separately, allowing you to summarize data for detailed analysis and reporting. This helps you identify patterns within your group data. Now let's look at the basic syntax. You start with the select keyword, followed by the column you want to group by, and then an aggregate function applied to another column. This is followed by the from keyword and the table name. Finally, you specify the group by keyword, followed by the column you are grouping by. Below are a few common aggregate functions, like count, sum, average, min, and max. Let's walk through a simple example of the group by clause. In this example, you have an orders table with the columns order ID, customer ID, product, and amount. The goal is to calculate the total amount spent by each customer. The query starts by selecting the customer ID, and then uses the sum aggregate function to add up the amounts for each customer, aliasing it as total spent. The data is retrieved from the orders table. The group by clause groups the results by customer ID. As you can see in the result, this gives the total spent by each customer. In this section, let's understand grouping by multiple columns. When you group by multiple columns, SQL creates groups for each unique combination of values across those columns. This allows for a more detailed analysis across different dimensions of your data. Here's an example. The first query selects the department and job title, then counts the number of employees and calculates the average salary for each group. This data is taken from the employees table, and the results are grouped by both department and job title, and then ordered by department and job title. Let's consider another example. The next query selects the year, quarter, and region, then calculates the total sales. The data is from the sales data table, grouped by year, quarter, and region. This creates groups for each year-quarter region combination. Note that the grouping order in the group by clause doesn't affect the result. All combinations are unique regardless of column order. However, the column order in the select clause determines the display order in your result set. Here, let's understand how to filter groups with the having clause. It is important to differentiate between where and having. The where clause filters individual rows before they are grouped, whereas the having clause filters groups after the group by operation is performed. The having clause can reference aggregate functions, while the where clause cannot. Look at the code below. This query selects the department and calculates the average salary from the employees table, but only for active employees. It groups the results by department and then filters these groups to only include those where the average salary is greater than $50,000. Here's the order of operations from selects and joins tables. Where filters individual rows. Group by creates groups. Aggregate functions calculate summaries. Having filters groups. Select determines output columns. Look at another example. This query selects the product category, counts the number of products, and calculates the total sales from the products table. It filters the rows to only include those sold after January 1st, 2023. It groups the results by product category, and then filters these groups to only include those with more than 10 products. In this section, let's see a few advanced examples of the group by clause. First, let's see using group by with dates. You can extract parts of dates to group at different time granularities. The query extracts the year and month from the order date and calculates the monthly sales from the orders table. It groups the results by year and month, and then orders them by year and month. Now let's see group by with case statement. We can use the case statement to create custom grouping categories. This query categorizes customers into age groups based on their age and counts the number of customers in each group from the customers table. It groups the results by age group and then orders them by age group. Let's see rollup for subtotals. The rollup is used to generate subtotals and grand totals. The query selects the region and product and calculates the total sales from the sales data table. It groups the results by region and product using rollup and then orders them by region and product. Now let's see group by with subqueries. This query combines group by with subqueries for complex analysis. This query calculates the average number of items per category. It selects the category and calculates the average item count. The subquery selects the customer ID, category, and the number of items for each customer and category from the purchases table. It groups the results by customer ID and category. The outer query then groups the results by category. Here, let's see common pitfalls with the group by clause and how to avoid them. The first pitfall is non-aggregated columns. This occurs when selecting columns that aren't in the group by clause without an aggregate function. If you look at the code here, there is an error since employee name must be in the group by clause. To solve this, either add non-aggregated columns to the group by clause or apply an aggregate function to them. The next pitfall is using where with aggregates. Avoid attempting to filter aggregate results with where instead of having. To solve this, use having instead of where to filter based on aggregate function results. The next pitfall is ignoring null values. Note that null values form their own group, which can lead to unexpected results. To solve this, use coalesce or if null to handle nulls, or explicitly filter them out with where department is not null. The next pitfall is performance issues, since group by operations can be resource-intensive on large datasets. To solve this, add appropriate indexes on group by columns, filter data with where. Before grouping, consider pre-aggregating data for frequent queries, and limit the number of groups with top or limit. Let's go through the best practices for using the group by clause. First, select only necessary columns to improve performance. Second, use where before group by to reduce the amount of data to be grouped. Third, create indexes on columns used in group by clauses. Fourth, handle null values explicitly with coalesce or if null. Fifth, use column aliases for better readability in results. Sixth, consider having versus where, and use the appropriate one for your filtering needs. Seventh, test group by queries on small datasets first. Here's a summary of key takeaways. Group by organizes rows into groups based on the values in specified columns. Aggregate functions like count, sum, average, etc. calculate summary values for each group. Each column in the select list must either be in the group by clause or used with an aggregate function. Use having to filter groups based on aggregate values after grouping. Group by enables powerful data analysis and summarization capabilities in SQL. Advanced features like rollup, cube, and grouping sets extend group by functionality. This concludes the discussion on SQL Group By. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.